All right, Year 12, welcome to the brave new world of vectors, and it's really going to be a big feature for the next month or two, really, because we're going to start from scratch and we're going to build our knowledge of vectors through to the point where we're writing complex numbers as vectors. So the next two sections really are going to have some vector work in them, and it goes really, vectors are a very straightforward concept, but because we look at them in 3D, we look at them as we look at them on planes in 3D. We look at angles between them in 3D, and so it goes from a fairly straightforward, one-dimensional concept of just a vector being a representative of magnitude and direction into only complex, because building things in three dimensions becomes more difficult to comprehend and visualize. So this does really scale from sort of 1 or 2 out of 10 in difficulty to some of the more difficult questions you get in an exam paper. So it's important that we slow down through this, and we do take time to get the basics right, so that we can build on those when things get a little bit tougher. So from scratch, we have a vector is simply have I got something there? Yes, I do. Is simply an object that has both magnitude and direction. Okay, so velocity is a vector, given that its velocity has magnitude, as in the faster you're going, the bigger it is, but it also has direction in that it can be negative, whereas speed is not considered a vector. So let's have a little look at some of the profiling of a vector, or the anatomy of a vector, if you like. So this would be, we would call this vector here AB, because it's directional. It's going in that direction from A to B. This point here is our initial point, and we have a terminal point up here at B. Terminal point. The arrow here is important. It's telling us we're going in that direction. If it's going in the other direction, so that we would say that if it's going BA is the negative of AB, so we would say that if we're going in the BA direction, then those two vectors would be equal. What else can we say about the vector initially? If we want to establish the length of AB, then we would write it like so. We often use these absolute value signs to denote length or distance. So this simply says it's the magnitude of the vector AB, which is just the length. But in vector land, we call that length magnitude, length of AB. Okay. You sometimes will see a vector will be denoted just as a lowercase letter in bold. So I'm going to try and, you might see it like, oh, that's a bit too bold, I think. We might see it denoted like so. So sometimes you'll see this AB could be written as just the vector A, but it will be clearly in bold and lowercase. So these are the different ways of representing this object known as a vector. Okay, how might we talk about it in terms of describing it? Well, I might get my ruler out again, and we'll want to represent here the distance we're going in a horizontal direction, and then the distance that we're going in a vertical direction. Like so, and perhaps we have gone across here by Well, I don't know, what does that look like? It might be 5, and this might be 3. So we would say that AB, we would say that the vector AB is equal to 5, 3, and that's how we would describe its movement. And this is referred to here as a column vector. Column vector, because it's written in column form. Column vector or component form. It's written in component form. So there's a little bit of language to get the hang of here. Okay, let's introduce perhaps another vector. So let's get our ruler out again, and might get a vector heading off in this direction here. There it is. So this one might be, we're going this way, and this one might be C. This one might be CD, and we might be heading off. I've got a little angle measurement down here. That's quite nice. We might be heading off like so, in the horizontal direction and in a vertical direction. I've got a little red dot there. Good. So that might be, or let's say this might be 7 along here and 2 here. So CD would be represented as a column vector because we're going 7 to the left and 2 up. We would write it as a negative 7, 2. Now let's say we wanted to add AB to CD. Let's see how we might do that. So let's do a geometric addition here of AB, which is this guy here, 5, 3, and we want to add it to CD, which is this negative 7, 2. So, okay, I'm going to get the ruler out and do a bit of work. So AB is my first one. It's going out at 5, what was it? 5, 3. So, what sort of angle does my AB go at? About 29, 28. So 28, I'm going to even measure him. Here we go. He goes at 28 and 1, 2, 3, 4, 5, 6, 7. You don't need to hear me say this. So what I've tried to do here is reproduce my AB. My AB here at, there's my B. Remembering AB, remembering that AB is equal to 5, 3 as a column. And my CD is 7, 2, or negative 7, 2. CD going this way at negative 7, 2, right? So geometrically, this is how we set up an addition. What we've done is remember that vectors are equal if they've got the same direction and the same magnitude. So we can have equal vectors like so, that are in different positions in space, but they've got the same. If they've got the same magnitude and direction, they're equal. So, in fact, while we're at it, if they've got the same magnitude but opposite direction, but parallel, then they're the negative vectors of each other. Right, good. So AB is here, CD is there. Now, geometrically, the sum of them is setting it up like so. We pick up CD, so there's AB just as a 5, 3. CD just gets picked up and placed so that C sits on the terminal point of AB and extends out. So what we end up with is the geometric sum is this distance here, or this vector here, from A to D. So from the initial point of A to the terminal point of CD. If we can just position that one like like so. So I can pick up that vector. That will be it just there. And if I draw that in, then that is from A to D. So AD is equal to, AD, the vector AD is equal to AB plus CD. Now, all right, AB plus CD, that's not a difficult calculation for us, because that's just 5, 3 plus -7, 2. And as you'd expect, we're going to add the horizontal components and the vertical components to get -2, 5, which is exactly what we would do. If we went from A to D, we'd be trotting along 2 in this direction, and we'd be trotting along 5 in that direction to get -2, 5. So that's how it's done in a geometric sense. Okay, one more thing. Let's have a look at, say, the magnitude here of AB. The magnitude of AB will be equal to, well, it's just, we're going to use Pythagoras, aren't we? So it's the square root of 5 squared plus 3 squared. 25 and 9 is the square root of 34. So there's the magnitude of AB. Okay, I think we need to head off and do exercise 11B now. I imagine we'll do all of those questions, and I'll see you in class or somewhere nearby.